Let's get started. Maybe a few people will join in. So anybody want to talk about the progress they made? I saw Mani's post and on the Slack. Anyone else make any attempts at submissions and get scores?
I didn't get any score, but I played about a bit with the question words, just what we'd been talking about last week, about sort of maybe trying to sort of sentences that are classified as being similar and take a look at the actual question word they use to see if you can sort of stop them being marked as duplicates when they're different questions. But I haven't submitted from it yet.
The when, where kind of.
Yeah, exactly. Yeah. Yeah, so like I looked into that like a little bit, but I haven't finished with it yet.
Oh, interesting. Mani, you want to share what you were able to submit and get? Mani, are you saying anything? We can't hear you.
Can you hear me now?
Yes.
Sorry. All right. Yeah, I was saying that. Let me share my screen.
Oops. Seems to have gone quiet again.
How about, can you see it now? Can you see the Jovian screen now?
Yeah.
Yes.
Okay. Yep. Yeah. So I took Steve's notebook, and one thing that I changed specifically was very specifically in Steve's notebook, take the two pairs of sentences and specifically take the embeddings from USC and use, I just add like one additional input, which is basically the difference of those two actually like inputs, and add as one additional layer. That's all the change that I made, but the rest of the things are like it's almost the same. It's the same as what Steve did. It did give me a slight increase, with respect to the validation accuracy and as well as the overall score. So it's the log. The score is basically the log loss. So it gave me a slight boost with respect to the score itself. It is actually based on the paper that I was a survey paper that I was reading, where I actually provided a link to that particular paper. Even in sentence BERT, they actually forget about the embeddings that they're using, but before passing it to the softmax, having this this element-wise difference between these two embeddings, it actually boosted the score. So that's what I just applied it here, and it did actually improve a little bit.
Yeah, interesting because I, just for reference, I did the same, but I did some couple of additional tweaks. So instead of just being the difference, what I did was I took the absolute value of the difference, and I also did I think, I don't know whether it's the same paper. I'll check later and post my link. I got the idea from some paper as well to try the absolute value of the difference between the two embeddings, and also the element-wise multiplication of the two embeddings.
I see.
So
Okay.
if you take the two embeddings as, embedding 1 and 2, then it's the TF abs of the embedding 1 and embedding 2 subtracted. And then the TF mul, I believe it is, but element-wise multiplication, TF math mul of the embedding 1 and embedding 2. And I got in the range of 0.33.
Okay.
So it got even better
I see.
results than what you show, which was somewhat impressive that with just those two changes, I didn't recall Steve's original score, but the score I was able to get was 0.33. But what is equally interesting for me was the fact that I just kept the model to be the same as what Steve had, just like you have in your, a very simple, just concatenate, take it through a couple of layers. But what's fascinating to me is I made a more complicated model, again, just linear, but with dropout and batch norm adding, and actually that gave me in the range, but it was worse than the simple model, which was kind of fascinating because it that wasn't what I expected. I'd expected the output, or at least I'd expected the result to be better, but it actually turned out it was marginally worse. But the first part of what I did, which is taking the absolute value of the difference and then taking the multiplication of the individual embeddings, that significantly improved it to a 0.33 result
I see. Okay.
on the final score.
Okay. That's
Where do you take the absolute difference? Sorry.
Just like if you go back to where you had that code money, I can just point to where you have the code where you're taking the difference.
It's here, the model creation.
Yeah. So after
So,
right there, Steve, where he has subtract, I
all
just
right.
did abs and then subtracted.
Okay.
Oh, and what I'm not sure is whether I did and I can share the notebook, but whether I did the subtraction after the dens or before the passing A and B through the dense layer.
Yeah, as Gutham said last week as well, in this model here, or in this notebook, you can swap the sentence 1 and sentence 2, which should obviously get better values as well, because like here it's just always putting sentence 1 into input A and sentence 2 into input B. But you could swap the columns and like sort of double your data or whatever. So
yeah.
Okay, interesting.
It'll give you a better score as well.
Yeah. So I did the TF app subtract right where he has, but I might have done it, before. I'll share the notebook later, but the concept is the same. I just did it right where he has the subtracted line, and then I had a multiplication line which multiplied A and B element wise, and then shoved in A, B, C, D into X. And here you just have the simple model, and the simple model actually gave me, I might have tweaked the numbers a little bit, but because when you concatenate, you go from, whatever these inputs are, you get 4x that. So I might have made the depth a little more before I get to a single output. And the thing, though, that was interesting was when I made the model deeper and with many more layers and batch normed it and introduced dropout and stuff, my results didn't improve a whole lot from the base, this simple model. So it seems, at least, what is interesting is it seems like the subtraction and the multiplication element wise contributed much more to the results than anything you did in making the neural network more complex. Also, one other point I wanted to make, if you go down to your plot of the training money,
Mm-hmm. Yep.
yeah, right there. I continue to see I got different numbers here. The validation, I'm pointing to this right side
Mm-hmm.
graph. What I also saw was this huge gap between, well, mine was a little less. It was 0.84 for the validation accuracy and about 0.87 for the training accuracy. But regardless, it still significantly it still had a significant difference between the validation accuracy and the training accuracy, which I thought would be, help to improve that by dropout and by batch norm and stuff, but that didn't really make a difference. It still continued to show a significant gap. So that was another thing I was focused on, is how can I improve the validation accuracy and help the model generalize better, because the training accuracy was headed up to 87, 88, but the validation accuracy flattened very quickly. So there, Steve, to your point, maybe, swapping the inputs and giving it more data, because usually data augmentation helps in reducing this gap, right? So that might be another technique to try that I have not tried yet.
And I think the subtract layer kind of makes it unsymmetric with respect to the question 1 and question 2, right? What you would want is absolute of the subtract, so that even if you swap the questions, you still have the same output.
Good point. I hadn't thought of it. I did the abstract, but you're right. Conceptually, that makes sense, because you're saying that regardless of which way you end up doing it, taking the absolute value kind of eliminates the
And even
sequencing ordering. Interesting.
and even if you have this trained model, if you just swap question 1 and question 2, you would end up with slightly different results, right? If it is a subtract one.
Right. Yeah.
So it should
Good
be
insight.
absolute.
It should be an absolute. I think
Yep.
that's what I think mistake. It actually says the absolute. I mistakenly did not actually take that into account. So they specifically mention, the absolute value of the element-wise difference. It's just that I don't know much about Keras, so this was the first time I was actually looking at what is exact. So yeah, you're right.
Yeah, and combining the element-wise product and the absolute differences gave me 0.33 something, 331. Which is fascinating. But what is fascinating is, it still gives you this huge difference. Yeah, I see similar 0.84 to, you're seeing about 0.79 something to 0.81, right? So that's about, I don't know, 2. And I saw even larger gap because it was 0.84 on the validation and 0.87 on my training set accuracy. So things that that's where, any other ideas from anybody on, when the validation thing flattens, at least in vision and stuff, you tend to try augmentation, right? In order to narrow the gap. Basically, you're not able to generalize. So that's where I thought dropout, batch norm, things would help, but just an idea if you folks are trying. Besides, think of ways to reduce this gap and you might be able to beat the 0.33. Yeah, that's really interesting that we both ended up at similar. Yeah, I'll also look at what triggered the thought in my head of doing the apps difference and the element wise and post that link. Anybody else want to share, Gautam, any progress on what you were trying?
Actually, I didn't get much time, but so I was not able to submit anything. But I completed the model, and it's not giving that great results till now. But I am yet to tinker on the model yet.
I see.
So yeah, there's still work to be done. But I can share quickly
Yeah,
if
no, that'd
there's
be great. Yeah,
okay.
go ahead.
You can see, right?
Yes.
All right. So yeah, I had shown all of this last time. So I just completed the model LSTM model, which is this one. Mm, yeah, this one.
Yeah.
So an LSTM which gives the representation of the question, and then I concatenate the representations and a dense layer.
Mm.
So you have an embedding for question one, embedding for question two, and LSTM layer for question one, LSTM layer for question two, and then you concatenate them,
Yeah.
and then two fully connected layers, which gives the final output.
Mhm.
So these are just the hidden states for both the LSTMs, hidden state and cell state, the initial stuff. Then I get the embedding for question one, embedding for question two. I pass those through the to the corresponding
RNNs.
LSTM layers. Yep.
Mm.
And then I get the outputs only for the last hidden state. I get the
Mm.
outputs. Yeah, that last hidden state is by taking -1, because the first dimension is the sequence length. So I want the last sequence, the last words hidden state. So I take -1, and then yeah, and then I concatenate the output of question one, question two by the second dimension, and then the fully connected layer one. So now concatenated output has a dimension of 2 times hidden size.
Right.
Since I've concatenated it, then I pass it through the first fully connected layer, which gives
Mm.
me hidden size, and then the final output.
Okay. So you take it through like a two-stage linear network.
Yep.
How big is your hidden state?
512.
512. Okay.
And I use glove 100 dimension embeddings here.
Oh, okay. Because there is also a 300 one, right?
Yes. Yep. Yeah. And
512, 512. So you go from 1024 to 512 to 1,
yes.
right?
Yep. 1024 to 512. Yep. Okay.
Just a thought, you might want to get the 512 to 1 through maybe
A
little,
dropout.
well, yeah, that, or stage it like, go from 512 to, I don't know, 128 to 32 to 1 or some such thing. I mean, just something to try, not the most
Yep.
important thing, but.
And yeah, this takes the question one and question two as the inputs, and the other parameters. So this is how I move the glove embeddings. I mean, I set the glove embeddings as the weight of the embedding layer. So model embedding q1 dot weight dot data dot copy, and that I set it to the vectors of my question one. Yeah, the glove vectors basically. I mean, yeah. So yeah, did this make sense?
Um,
I'm just setting the weight
I
of the embed. with the glove embeddings. That's it.
Weights of the embedding. I'm still not getting it. Maybe I'm slow.
Um,
What are you doing?
so
Which? So what layer weights are you
the
making?
embedding layer has a dimension of my vocab size times my word embedding dimension, right? So suppose my vocab size is 20,000. So it would be 20,000 times embed size is 100 here, since I'm using 100 dimension glove embeddings. So my embedding layer is just it's of size this, and there's an embedding layer for both of the questions, right?
Right. Each,
And
but don't you take the questions through the same embedding layer, because it's just the glove translation, isn't
yeah,
it?
they are actually the same. Yeah, I believe these two are actually the same. Embeddings weight Q1 and Q2 should be the same thing,
Right.
because
Because you're
they are
taking
just
it through
glove
the same
vectors.
embedding layer, right?
No, the embedding layers are different. Embedding Q1 and embedding Q2, they are different, but the weights would be the same. Yeah, I think the weights would be the same. Well, yeah, no, the weights won't be the same if the vocab is different for question 1 and question 2.
Yeah.
Like if
If you use, so you are using different vocab sizes for the two question.
no, the sizes are the same, but the words themselves could be different, right?
Right.
Oh, okay. Okay, this is confusing for me as well. Let me just print out if I can. I'm not sure what type of object this is. Okay. Yeah, they are the same, I guess. How do I check equality in?
So
Okay, they are different for some of the words.
Can't we use the
Some of the
same
values are different.
vocabulary in the sense that combine question one and question two and create a one vocabulary and use it?
So your question is, can we do that, or should I do that?
Yeah, can we do that? Because no, it's just naive question. I do not
Hmm.
know that.
Uh,
And increase the vocab size if needed.
well, actually the embedding layer for each question has to be different, has to be separate, because they are different LSTM layers. I mean, they are different networks, and then you finally concatenate the output of each network, right? So that's why we have separate vocabs for each of them.
So, are you going to be training this embedding layer, or are you wouldn't, right?
I'm not sure what the default is. I think it is frozen. I'm not entirely sure.
Yeah, because I was thinking if it is, then anyway. But yeah, if you can post share this notebook
Yes.
at, when you feel comfortable, then that'd be interesting, because definitely, yeah, it's a very fascinating idea to play with and see what happens with different options and stuff.
Yeah. So the confusing thing is, yeah, the vocab is different for question 1 and question 2, but okay, the weights, yeah, so the layer weights would also be different. Yeah, the layer weights are just taken from the glove embeddings, but since the words in each vocabs are different, the values would also be different. I hope that made sense.
Yeah, but I was also leaning, and that's why we need to try it and drop the shapes and um, towards kind of thinking what Mani was asking, which is, if you can use a max vocab of, I don't know, 40,000 or whatever, and then it's the same for both sets of uh, questions. It's just the glove embedding, because if you go back to the picture that you were showing, it's just that the embedding taken through, oh, there is another embedding. Yeah. So it's not the embedding that you are having, that you shared, is the green embedding layer that's shown here, which is after the glove embeddings, which are coming in as individual tokens or embedding in that oval, right? Is that the way you're thinking about it?
Yeah, the embeddings are the glove embeddings that are fed to the LSTM, and the last state becomes the representation. That makes sense. I feed the glove embeddings as the input to an LSTM, and the last state of that LSTM is my representation.
Right. But then see, that's then because you're using the embeddings, um, why would you need the weights of the embedding? Because you can think of the embeddings themselves as just inputs or
Okay, you're
to the,
saying I could share a same embedding layer?
yeah, that's what at least, I mean, that's, I might be missing something, but it's more a open question. I don't know.
Yeah. I don't
I'm
think that.
wondering whether it makes sense. You have to actually do the coding to figure that out. But yeah, so that's why you'll have to
Yeah.
work.
Yeah, I think it won't be a problem if you share the embedding layer. Yeah, I think that could be also be done. Yep. Okay. Yep. And
Train it.
yep. Train. I mean, in PyTorch, you just have to write so much stuff. It gets messy, and yeah.
Yeah.
Yeah, there's nothing much complicated here. Just training it
Right. Training and
and
then doing the
eval.
eval.
Since I have, yep, question 1, question 2, and the target, and the model takes in question 1 and question 2, and yep, loss is binary cross entropy, and eval is the same without the back propagation.
Right. Yeah.
Yep, and I'm not getting really that good accuracy on the validation set. I'm getting like 74 or so.
Uh,
Yep.
Dinesh, a quick question. So is it the same? For words that are not in the vocabulary, is it the same as, like, it'll initialize it with some random vector during the evaluation for
Yeah,
your?
I'm not sure entirely how it treats unknown words.
Because I see like there is 20,002, which is
Mm-hmm.
why I was wondering those extra two might be for the unknown kind of thing, which gets added. I saw your vocabulary was, though you set up
Yeah.
20K, it was actually 20,002.
Yeah, I did see that. Yep, I would have to see if torch text build vocab does something like that.
Yeah.
Extra vocabs.
by default, it's initialized to 0 vectors.
Okay, does it say that?
In the second one, by default, initialize out of vocabulary word vectors to 0 vectors.
Okay. Okay, yep, I'll take a look at that. Yep, that's all I had. I'll share this notebook.
Yeah,
probably
but
tomorrow.
that's a
Yeah.
fascinating approach, though, because it seems like that path ought to lead to better results. Is my gut feeling than already using something like USE, but yeah, we'll see.
There is one thing I wanted to share. So I posted a link in the chat. If you click on that, so Semantic Scholar. So share. So this paper, I got the reference from the earlier link that I shared from the pre-trained transformers, because it was the pre-trained transformers paper. It was actually a survey paper about for the information retrieval. So hold on a second. I was actually reading about it, and hold on one second. So basically, this specific paper was, they were actually really talking about how they actually, how BERT can be used for like ranking purposes. And since it's a survey paper, they actually before going into ranking, the first thing is to actually compare the query and the document to actually turn it into a semantic similarity problem first. So they did a little bit of survey on how this actually emerged. So a lot of useful insights actually came, like learnings from how they are actually arrived at sentence BERT. So I definitely recommend checking it out. One particular thing that really interested me was specifically this paper, which is this universal paraphrastic sentence embeddings. And one thing which really fascinated was they actually did, instead of using generic, they specifically ran learn the sentence embeddings from specifically on a given data set. And the results, hold on a second. So in this case, they actually compared it with multiple data sets here. And in fact, what they did was, this is very specifically these two columns is what they actually they specifically did initialize with glove embeddings and then performed weighted average of those embeddings. And in fact, it actually performed well compared to these LSTMs. The code seems to be written in Piano, so I do not really understand much. But definitely check this out.
Yeah, in fact, Mani, the thing I shared, I think even there in the meeting early on that I shared the links on, it's there in the Slack.
Okay, I'll check it out.
Not this one, but my point was that, and unfortunately I haven't gotten around to implementing that, but the idea is that I want to do it, but using glove vectors, just simply doing the min, max, and average, and then using that to predict, and that and use that as a baseline. And what this seems to suggest is that you will get a pretty good baseline from that. I wanted to compare that with, for example, the use the universal sentence encoder and what results Steve and you and have gotten so far from it, and compare it to just averaging the glove vectors and doing a min max average of each of the sentences and then and concatenating them and passing them through a linear classification layer, because that itself is supposed to give a fairly good benchmark. So that's something I haven't gotten around to, but I definitely, it's on my list of things to try, because I think that seems to be, everything I've seen says that that would give a good benchmark, but I haven't done it yet. So I don't know.
Okay. Yeah, cool.
And by the way, to one other point I would make, and I kind of wanted to hold off, but since you brought it up, the eventually, after we have tried a bunch of these different techniques and stuff, eventually what this task, the questions is duplicate task, turns out to be a combination of paraphrasing sentences is one part of it, because that leads you towards kind of comparing whether two questions are equal, and the other is similarity. So if you look at benchmark of NLP tasks, and we'll do that later, I want to kind of us to go through many more of these different techniques and stuff, then the eventual benchmark state of the art that we would end up having to compare is a combination of paraphrasing sentences and sentence similarity. So anybody else want to share what they're able to, even if not submit, make progress on their?
What did you mean by a combination of paraphrasing and sentence similarity?
Sure. So see, the issue as I typed into it, Gautam, was the fact that this particular task, you part of the reason, and I just started to look at what USC does. I just downloaded the paper and a few other state-of-the-art results in this domain. And when I say in this domain, what I mean is the task is one of saying, are these two questions duplicates of each other? And in order to accomplish the task, the two closest related NLP state-of-the-art tasks, the way they break it up, seem to be sentence similarity, because that's this, is this sentence similar to this sentence? Because if they're similar, then it points you that they may be duplicates. But similarity doesn't say it's exactly the same, right? Similarity just says these two are close to each other. So in NLP, general broad, under NLP umbrella falls a variety of tasks, right? Like sentiment classification, neural language inference, things which again are subclasses that are grouped together, tasks. And one of the tasks seems to be similarity tasks. So find out whether these two sentences are similar, these two paragraphs are similar, and things like that. But sticking with sentences, are these two sentences similar? So there are techniques for similarity of sentences, which has state of the art for the algorithms that just perform that task. But that task alone, as I see it, is not enough for what we are setting out to do. So that's kind of one thing which falls close to what we are trying to do. The other task that falls close to what we are trying to do is the paraphrasing, because paraphrasing enables you to get at the semantics or the meaning of the sentence. So if two sentences, and in fact in paraphrasing case they go on to paragraphs and stuff, but if they end up with the same paraphrase, that means they're saying the same thing, and thereby you can help to decide whether if a NLP algorithm does a good job of paraphrasing something, say paraphrasing a sentence, then you would think that that same thing ought to do good at our task, right? Because it's paraphrasing one sentence and paraphrasing other sentence, and if the two paraphrases are the same, then that ought to say it's a duplicate. So from that standpoint, I was saying under the NLP task classification broadly, from what I could tell, these two tasks fall close to what we want, but neither of them is a perfect match. So it's not as simple. That's part of the reason why USC and other things don't automatically give us the best results that we, it's not as simple as just putting it through USC and out pops our best answer, as we have begun to see, because it's not exactly doing what we want in our case.
So
You would still do a sentence similarity of the paraphrases, right?
Yes.
Okay.
So that's what I meant by some combination of these two types. There may be other thing too, but at least these two broad group of, so algorithms will do good in these two broad classes ought to be helpful to us. Right? If they're doing a good job of paraphrasing, then they ought to be helpful in deciding whether it's a duplicate. If they are very helpful in deciding if two things are very similar, then so the sentence similarity is a big category in NLP, just as apparently paraphrasing is.
But isn't paraphrasing a totally different task altogether? Like how, so you would need another paraphrase generator. Is that how it works to generate?
Haven't, and that's why I was curious, or at least I'd bookmarked and looked at the state of the art, but I hadn't dived into it. But if you look back at what Mani had shared, that was a paraphrasing oriented paper, right? Mani, if you can put that up again.
I was actually thinking in terms of learning that representation of that sentence. That's what I was actually like thinking.
Yeah, but that's the encoding part of the paraphrasing, right?
Right.
Because you can always use the encoding part of the paraphraser, if you will, right? And then put that to use for further combination.
So you're not generating actual paraphrase text, right? So
Yeah,
in a
no.
way,
In fact, if you
that's
go
the
back to
sentence.
just sharing if you just share the summary thing,
The summary
that
here?
was, yeah, just the thing.
Yeah.
Yeah, right there. If you go up, see here, he says the problem of learning general purpose paraphrastic sentence embeddings, right? So if a sentence embedding gives you a good paraphrase, that ought to help us in deciding whether two sentence embeddings which have same paraphrase are, one would think, would be duplicates. But that doesn't always hold true, which is why I said that it is a combination, or it's not as simple as just using one of the universal sentence encoder or a paraphrastic sentence embedding or anything else, because we would have to do multiple. And that's where even on this summary, you can see that they talk about 3 supervised NLP tasks: sentence similarity, that's the other, as well as paraphrastic sentence embeddings, which, by the way, to kind of summarize this, I can share the link, or I forget now whether it was a Medium post or something. If I may, Mani, I'm going to.
Yeah, please. Go ahead.
Let me see which one of these windows are this one. Okay, let me see whether. Okay, I think this was to. So it's taking a while coming up. So this particular post or blog post talked about many things which I thought the current best. Sorry, my computer is acting up. Can you folks see my screen or?
You're seeing a, yep.
Okay, so this particular blog post, the current best of universal word embeddings and sentence embeddings. It's a couple of years old, but I thought it kind of gave a good summary of where things were at least as of 2018, and talked about different things related. We just start off with bag of words. I'd mentioned skip thoughts um, in when we discussed it last time, I think. And then there's something called infer sent, and then obviously eventually they get to Google's universal sentence encoder, and talk about some of this is dated obviously, but it leads into and takes us through how we get to this universal sentence embeddings and what they mean. The rise of universal sentence embeddings. And this is what I meant, Mani, earlier when I said that averaging a sentence's word vectors, which I think Yuri had also in an earlier session referred to. This was kind of like the default before the universal sentence encoding and other techniques came into play. You just take it, and by the way, I wanted to also look into this paper because, of course, when he says last year, he means 2018 or 17, and using a linear weighted combination of word vectors, and then doing something fancy like common component. I don't know what that is, but I intend to kind of chase it down and see whether that can be implemented, because it seems like he's saying that it gives very good results just using the bag of words. Right. And then another paper which also uses the same thing or similar techniques, just using bag of words. And then going beyond simple averaging, you get to skip thoughts, which I'd mentioned last time. And I think the link is there on Slack. The beauty of skip thoughts is the fact that it's does unsupervised. So you don't even provide the supervised results. It just does it based on unsupervised sequence of sentences. And subsequently from there, it leads us to the infer sent. And this is where I found this idea of, here you see the picture, and this is where I got the idea of trying what I did with the vectors, which is the absolute value of the difference. As Gautam pointed out, there's the reason why it's an absolute. And then I also added the element-wise multiplication. So that's the source of why I tried what I tried. And then these different Google's general purpose sentence representation, and then the universal sentence encoder. So this link or this Medium post seemed to take us through kind of like the thought process and the evolution of what we are trying to do. So I thought this was an interesting post because it takes us, there may be other techniques as well, because I think to Mani's point, there are Siamese comparison things that I had bookmarked that I'll share later as well. But this one seems to take us from a very basic averaging of bag of words to skip thought vectors to universal sentence encoding, or I haven't looked at the infer sent um, mechanism either. So something I'll post this link, and if people are interested, they can try implementing some of the suggested methods or techniques and see what results we get. Comments or thoughts?
The fascinating part, Srinivas, is when I read this survey paper, how these ideas evolve and build on top of each other. It's really fascinating. So,
Yeah.
kind of before we jump into BERT, the pre-BERT, evolution actually helped, and what before these BERT actually came in, what was the simplest thing they would have tried, and and that's my plan. Try it exactly what they did.
Yeah, and in fact, Gautam is doing also the same thing, right? He's just taking the. That's why I definitely want to see where his approach ends up, because I think that ought to give us a very good baseline. It's a matter of playing with parameters and tweaking things and trying various things, and you know, uh, because the glove vectors he's trying to get through LSTM and then get that trained, which is somewhere between just a bag of words and then moving on to the next things, right? So that's why I'm fascinated. And to your point, is it the case that, and I'd be interested in reading the paper you pointed to see whether they say that LSTMs or GRUs do not give better results than
Yeah,
just simple averaging?
yeah, that's what they actually mentioned. At least the results, if you see the results, like the figures and tables, uh,
Mm-hmm.
LSTMs did not perform well on these kinds of similarity oriented tasks, but they did perform well on the classification. Um, um, but that's the results based on the data sets that they tried.
Mm.
But it's a 2017 or it's a 2016 paper. So
Yeah, this is also 2018. So I think if I recall correctly, the guy wrote this sometime in May of 2018. So it's about 2 years old by now. So
yeah.
any other things people want to share or discuss? Anyone?
I guess I can wait for Gautam notebook. I still didn't catch how glove embeddings are being used as weight. Is that the same thing as saying that basically each word is going to be encoded with glove as a glove embedding?
Yeah, so in embedding layer, usually you just take your embedding layer size would be vocab size times embedding dimension, right? And then your
Hmm?
input would always be the words vocab number, right?
Hmm?
Suppose suppose your 10th word is join, so you would just input the number 10 and it indexes into that embedding layer at the 10th position, and that embedding is input to your LSTM.
Okay.
That makes sense. So
Okay.
that's why your embedding layer is just the
Lookup
glove
table.
embedding in the order of your vocab.
Okay. Why would it be then different on sentence one, like
Yeah,
coming from
now that I
sentence
think
one or
about it,
sentence two?
yeah, I think there won't be any issues if you share the embedding layer, but maybe there would be issues if you want to make it trainable. If you want to make the embedding layer trainable, then since the gradient flows separately, uh, since the gradient flows separately along the two forks of the network,
Mhm.
uh, maybe I'm not sure how good the training would be in that case.
Yeah, if you train, I agree with you, Gautam. If you train the embeddings, or if you even fine tune them, then yes, then you would need the embedding table,
Yeah,
because you need to back propagate to those
yeah,
values. But if you freeze that so that your embeddings are not allowed to be fine tuned or
yeah.
trained,
In that case, you can just
then I'm thinking that you could share and not
yeah.
even let that be a factor.
Yeah, because when you are not training, it's just a lookup table, right? It's not doing
Right.
anything. It's just a
Exactly.
lookup table where you index each
Yes.
row. So then it
It's
wouldn't
just
matter.
translating an index into some
Yeah.
100 sized vector. That's it.
Yep. It just indexes the row and gives it.
Right. And out pops the embedding.
Yes.
Yep.
So in that case, yeah, you could share the vocab and just have a single embedding layer.
Right. That's what I was thinking. But if you're training, then yeah, I agree with you. Then each of them needs to be fine tuned. So, anybody else want to share anything more? Victor, Joseph, Alvaro, any other thoughts or inputs people want to, or Tayo want to contribute? Yeah, so there are multiple techniques. I'm definitely fascinated by what you're trying, Gautam, and also what Steve is doing with the question words separation. And as I said, I've been one thing I wanted to try, but I think I was lazy and tried the low hanging fruit based on what Steve had already done. And I saw this U minus V, and I definitely wanted to try that. But I think I may want to spend some time and try the uh, simple bag of words baseline as well, to see where that ends up for reference. But what is also very fascinating to me, I just was thinking about it, would welcome your comments, is the even with all the progress of BERT. By the way, another idea is Yuri had shared this. We could also use SBERT, which is sentence BERT, and see where that, because that's again a sentence encoding, if I recall correctly. So you could probably use that instead of universal sentence encoding and see where that gets you. But the point being that with all this done in the 2 years, it's still the case that the XG boost and other techniques that people have used have gotten them far better. The best score is 0.11 3 years back. So I thought that was something to reflect on as well, that um, it's depending on the tasks, that traditional techniques seem to and even 3 years back have gotten pretty impressive results.
Didn't we see QQP being mentioned in one of the papers that we read last week, I think, in Joseph's session, I believe.
Yes.
So wasn't that
Yes.
BERT or something?
I thought it was sentence BERT or something like that.
Mm.
I forget now which paper, but you're correct. Definitely, we read and or we looked at that, and that's why I was saying, what we haven't tried is using what you and Yuri had pointed to, this SBERT, right? Which is, I think, sentence BERT, which is BERT applied to sentences. I think I haven't looked at it. That's another simple thing probably can be tried, because that is BERT encoding of sentences, if I recollect. Yuri, is my recollection correct, or you have anything to
Oh yeah,
correct?
yeah. So they, I actually haven't read the paper fully, but they basically use CME's networks approach and to train it.
Hmm.
and they actually, I think I shared it.
Yeah.
A couple
It's
times
there on
ago.
Slack.
Yeah, it's they actually have a software that, and they're actually suggesting like for questions like what kind of losses you want to use. So I was gonna try, try to use it, but didn't get to it yet.
Yeah. By the way, that's what you brought up an excellent point, and that's something we didn't have time to get into, but we should in one of our future meetings. Is I read a little bit about the two losses, and they're very fascinating in how they actually help. Um, I think I forget the terms now, but those two losses are fascinating in how they contribute to the task at hand. So that's another thing in general that, and I think Steve is very familiar with it and stuff of how using the appropriate loss for the appropriate tasks really helps improve performance and scores and things like that. So that's something else, that comes out from what Yuri had shared. And um, take a look at the link he had shared and see whether you can implement the SBERT method and get quick results. And also the two losses, I forget the names of the two losses, but they seem fascinating in what they enable um, and contribute to the task.
I
We'll
just
discuss
posted a
that in
link.
one of the upcoming.
Sorry,
Go ahead,
I just
Gautam.
posted a link, which is the current leaderboard on Quora question pairs. And if you look at number 14, it's simple word embedding based models and pooling mechanisms, which is above BERT, simple word at 15.
Mm.
So that's something to look at. And there is no, yeah, that's dominated by transformer models and no mention of LSTMs or anything. Obviously,
Interesting.
yeah.
Why do you think that Distilbert is so much better than BERT? Since it's a condensed BERT, so I don't understand why
Yeah,
it
that's
should be
interesting as
better.
well. Yeah. And it's significantly better, not just, yeah, it's 89 and 72.
Yeah.
Doesn't make sense. Yeah. Yeah, we would have to see the actual model, maybe because it's similarity. Not sure how exactly they did it.
Well, it's
See,
coming from Hugging Face, so they might have some kind of special encoder that goes with it that's better than BERT's. Because remember, in Hugging Face, they have special encoders that go with each model.
actually, I think they do it. Hugging Face just gives you an easier way to encode it, but still you would have to encode it the same way, I believe.
So it's just
Yep.
can you folks see the screen? So this is the one you're referring to, right?
Yes.
Yeah.
The 14th one is the
So which
word
is
embeddings.
so the 92.3 is the best results so far, right?
Yep.
Yeah.
And number 14 is the simple word embedding ones.
Yeah. And associated pooling. So I guess the pooling matters as well.
And I think one thing that you can do with BERT is, since BERT can take two sentences, you can just input two questions with the SCP token in between, and you can take the CLS and you can just predict the similarity. I don't know if this would work very well, but
Yeah, those are the various uh, tricks and twists that are worth trying to see, how well um, things have gotten compared to uh, the baseline, if you will. And the other thing, this is on the Quora question pairs itself. I would imagine, right? Yeah,
Okay,
Quora
it
question
says
pairs.
question answering on, maybe it's a different task. I'm not sure.
Yeah, that's something. See, because that's answering, right? Quora question
Okay, yeah.
pairs data set. Because I haven't seen, in the duplicate thing, at least I hadn't seen when I checked any results above 83 in a different reference. So this is maybe a different task, Gautam. I'll have to look at it.
Yep, looks like that. Yep.
Because when I checked at something else, I didn't see, it was still in the 80s, whereas this is into the 90s. But worth checking out whether it's the same task or a different task. Okay. We should do that. Any other comments or thoughts, folks? 10 after. So let's continue to submit. If you haven't, just try, take one of the notebooks, play with it. As I said, lots of different ideas to try. You could use SBERT. You could use simple bag of words, do the average, min, max, submit it. You could try playing around with Gautam's notebook, with Steve's notebook, original. So just make some submissions, play, and share your results. We learn by everybody conducting different experiments on different set of tools. So